Very good morning. In today's video lecture, you can see the new topic, that is the Bayesian approach. Okay, Bayesian estimator or the Bayesian approach. The Bayesian approach is very important for the examination point of view, as well as in case of estimation. Okay. Bayesian approach. So before coming to the Bayesian approach, as well as the how to calculate the estimated value, we should see some of the difference between the classical approach as well as the Bayesian approach. I will first discuss that one, and based upon that, I will come across the derivations of how to calculate the estimator using the Bayesian approach. Okay. So let me start with the classical approach. In the classical approach, the parameter of interest is theta, and that is to be assumed to be deterministic, but that theta will be an unknown constant. Whereas in case of Bayesian approach, we will assume that theta is nothing but a random variable whose particular realization value we must estimate. That's it. In case of a classical approach, we are not considering the theta as a random variable, whereas in case of Bayesian approach, we are considering theta is a random variable whose particular realization value that we must estimate the realization value of that random variable. Okay, that I write here. The first point, in the classical approach, the parameter of interest, we call this interest, the classical value, the parameter of interest. Okay, interest, theta is assumed. Okay, assumed to be a deterministic but, underline that word, deterministic but unknown constant. Unknown, I will underline that word. Okay, but deterministic but unknown constant. But in case of in the Bayesian approach, Bayesian approach, we assume that theta is a random variable whose particular realization bar, I call this value, we must estimate. I think that word is very clear to you. Okay. So in this approach, if some prior knowledge about theta is available, it can be we can incorporate into the estimator by assuming that theta is a random variable with the given prior PDF. That is important. That's very important. That means what I am telling is, if you know the prior knowledge about theta, or if the prior knowledge of theta is available, then you can incorporate the value of theta into the estimator, and by assuming that, in that condition you have to give an assumption there, assuming that theta is a random variable with the given prior PDF. Okay, that was right. So in this approach, if some prior knowledge prior knowledge about theta is available, it can be incorporated so it can be incorporated into the estimator by assuming that theta is a random variable with the given prior PDF. Okay, so the Bayesian approach, Bayesian, the Bayesian approach, when applicable, can improve the if you are utilizing the Bayesian approach, the accuracy of the estimator can be improved. Okay, we can improve the estimation accuracy. Okay, underline that word. We can improve the estimation accuracy. Okay, so this is the case in case of a Bayesian approach. So if you are any type of estimator you can utilize, but that if you want to improve the accuracy, then you have to go for the Bayesian approach. Just we can see the comparison between the classical approach as well as the Bayesian approach. Okay, comparison. Right, in the Bayesian approach, first point, in the Bayesian S-Y-E-S-I-O-N, in the Bayesian approach, we will find estimation error as defined as what? That is Bayesian approach. We are giving estimation error A minus A cap. Whereas in classical approach, it will be A cap minus A. I will call this as BA, Bayesian approach. Okay. Whereas in case of classical approach, call it as CA. That is nothing but A cap minus A. Okay, that's the first point what I had to discuss you. Second one, mean square error, that is MSE. mean square error is defined as for both Bayesian and first of all I will explain with the Bayesian approach. That is, in case of Bayesian approach, the mean square error is defined as, that is Bayesian approach, I can call as BMSE of A cap is given by expectation of A minus A cap square, which is nothing but double integral of A minus A cap square P of x of A dx dA dx dA. Okay. Since A is a random variable, A is a random variable, the expectation operator is with respect to joint PDF. Okay, is with respect to the joint probability density function. Keep in mind, okay, that this thing I have explained in the first session, that is in the class joint PDF and SL PDF. Okay, so joint PDF, that is P of x of A. Okay, whereas in case of classical approach, right, mean square error, that is I will write MSE of A cap is given by integral A cap minus A square P of A dx. This is not double regular, it is only single regular. Okay, that's the second point. The third point what I have to discuss is third one, in Bayesian approach, the single MSE figure obtained would be an average over the PDF. Average over the PDF. Okay, that's the case. In case of Bayesian approach, the single MSE figure obtained would be an average over the PDF, whereas in case of classical approach, we obtained MSE, we obtain an MSE for each assumed value of A, for each assumed value of A. Okay, that's the third point. The fourth point is, in case of Bayesian approach, MSE will not depend on it. That is, mean square error will not depend on A. Whereas in case of classical approach, MSE will depend on A. MSE will depend on A. That is, MSE will depend on it. That is, observe expression for, you just observe the expression for MSE in case of classical approach. Okay, what I have discussed to you. Observe the expression for MSE that I had discussed in the previous case. Okay, these are the four things, four difference between the our classical approach as well as the basic approach. Okay, regarding the MSE as well as with the mean square error of Bayesian approach as well as with the mean square error of classical approach. So don't confuse with them. So you can go for any method for finding out the classical approach. If they are specifically asking regarding the Bayesian approach, you should go for the Bayesian approach only. Because the Bayesian approach will give you that is in case of Bayesian approach, there is the theta, the values of theta is assumed to be the random variable, and we will get what is the estimated value will be accurate in case of Bayesian approach compared to that of any other method. Okay. So we can see estimated that minimize the Bayesian MSE. Estimator that minimizes Bayesian MSE. Okay, as we can see, we have what BMSE of A cap. We have BMSE A cap, which is given by double integral A minus A cap square P of x of A dx, P and the probability of dx dA. That I can rewrite as integral. I will bring in this the integral A minus A cap square P of A bar x dA, that is in square bracket, into P of x into dx. Okay. Clear? Since P of x is greater than or equal to 0 for all x, if the integral, that is the what I call as inner integral, okay, inner integral, okay, can be minimized. Inner integral in the above expression can be minimized for each vector x, that is the vector x, okay, then the Bayesian MSE will be minimized, okay. So we have what dou by dou A of integral A minus A cap square P of a of x dA will be equal to, that is the inner, I am taking about the inner integral, that will be equal to integral dou by dou a minus a cap square p of a bar x of dA, which is equal to what? Integral 2 into a minus a cap into a, I will take it with the dA cap. Okay, that is good. We have to replace with the dA cap, minus 1 p of a bar x into d. This I will take as vector x. Okay, vector x. Clear? So you just equate this to 0, equate into 0, you will get, sorry, equate into 0, we get what? That is integral minus 2 into a minus a cap into p of a bar x into dA equal to 0, or minus of a, I will multiply with a, that is a minus a cap, p of a bar x dA plus minus 2 will be go outside, it will be 0 plus minus, yeah, correct only, plus a cap. I am just multiplying with a minus a of this one. 2, if you go this one, I can take 2 outside, so equating to 0, that will be, so that will be 0. You will have only minus of something, so it will be minus a minus a minus a, it will be plus a cap into p of a by x, p of a bar x into dA equal to 0. So, okay, or so the second term will be a 1, that is minus a p of a bar x of dA plus a cap into 1 will be equal to 0, or it is nothing but a cap is nothing but integral a p of a bar x into dA. So okay, you just make it in the box. That is the value for a cap, estimated value, that is a into p of a bar x into dA. Okay, similarly you can write theta cap is nothing but what? Theta p of theta bar x into d theta in general. Okay, or I can write theta cap is nothing but expectation of theta of x. Clear? Therefore, I write, therefore a cap is the mean of the posterior PDF. PDF P of A of x. Okay, underline that word, posterior PDF. So I will give one note. Note 1. Note 1. P of A is nothing but integral P of x of A dx may be thought of a prior period of as the prior PDF of A. Okay, and note 2. Note 2, we have what? P of x of A equals P of x of A into P of A, that is nothing but P of A of x into P of x. Okay, that already you know. That is therefore P of A bar x can be written as this thing I have already discussed in the first step while taking the estimation. Okay, P of x of A into P of A divided by P of x. Okay, that you can write it as P of x of A P of A by P of x. I can write it as integral P of x of A dA. So in general you can write P of A of x is nothing but P of x of A into P of A into P of A divided by integral P of x of A into P of A into dA. So keep in mind this also, okay, for calculating A bar x. So we can see in another video regarding the examples of Bayesian approach, that is the DC level in wide Gaussian noise as in case of any other examples. Okay, thank you for watching this video. In the next video lecture I will come across with the examples of Bayesian estimator. Thank you.